Hello and welcome to another Major Makeup Math movie where you get to play the part of the therapist and solve all of math's problems. Today we're going to be working with lesson 2.2b, triangles and slope. This is going to be on page 61a and is an extension of lesson 2.2. So this might take a little bit. Let's go ahead and turn to page 61a. And we'll get started. Alright, so the first thing that we're going to talk about, this isn't in your book, but I just want to clarify, we all know what a right triangle is. And a right triangle is simply a triangle that has a 90-degree angle, okay? And when you see it in your math book and in other pictures or drawings, you'll know that it's a right triangle because it will have this little square in one of the corners, okay? This means that we have a 90-degree angle, and that means by definition that we have a right triangle. This is the 90-degree angle. Across from that 90-degree angle we have the hypotenuse, and on each side adjacent to that 90-degree angle we have a leg. Okay, so leg, and the hypotenuse. Alright, so the next thing that we need to cover is similar triangles. And the first thing that we'll do is we'll talk about how to name triangles. Let's discuss this triangle up here. This triangle's name is ABC or CAB or BCA, well, however order you want to say it, but it creates a triangle of the three vertices. And a vertice is where two lines meet. So here's a vertice, vertice A. Here's a vertice, vertice C, where this line meets this line. And this vertice up here is vertice B. And we name a triangle side by naming the 2 points that are the endpoints of that line. So the red side is side AB. It can also be named side BA. So it can be AB, you'll see it written like this, or it can be BA. All that's talking about then is this side right here. Okay. Now the blue side can be named AC or CA, and the green hypotenuse can be named BC or CB. That's how you're going to name a triangle. The corresponding side is simply the same side that's in the same location on a separate triangle. So AB has a corresponding side in a second triangle. That corresponding side is DE. We have side AC in our first triangle. It has a corresponding side in the second triangle. That's DF. And then last, we have the hypotenuse, BC, and its corresponding side is going to be EF in our second triangle. So the corresponding sides is simply a side in two triangles that are in the same location. Now the second part to figuring out whether or not we have similar triangles is if they're proportional. So we have to set up a proportion, which we've done before. You're going to take one side, AB, here, and you're going to put it over the corresponding side, DE. Then you'll need another side, AC, which I put here, and put it over its corresponding side, DF. And if those two are equal, you'll have similar triangles. That was a lot. Let's do an example and see if we can make it make more sense. Alright, so here's example 1. We have triangle LKJ and PNM. Obviously they're different sides. LK is 7.5 and PN is 5. So this triangle is going to be bigger than this triangle. Our directions are asking us whether or not these are similar triangles. And in order to do this, we're going to have to set up a proportion with similar sides, corresponding sides, excuse me. So what we're going to do is we're going to choose a side two sides that we know the measurements for. We know LK, we know LJ, so we're going to use those. I'm going to start with side LK, and I know that the measurement is 7.5. So I'm going to do 7.5 on top as I set up my proportion, and I need to put it over the corresponding side of the second triangle. So the corresponding side of LK in this triangle is PN. The measurement of PN is 5. So I need to put 5 underneath 7.5. Now my other side of the proportion, I need to put LJ for the second side. LJ is 12. So I'm going to put 12 on top. And it needs to have the corresponding side of the second triangle on the bottom. So the corresponding side of LJ of the second triangle is PM, and its measurement is 8. So I'm going to put 8 on the bottom of 12. Okay? On the top of my proportion, I have the first triangle. So here's the top triangle measurement here, and this is the top triangle measurement, 7.5, 12. And on the bottom, I have the bottom triangle. So here's my proportion. What I need to do is I need to reduce these to see if they are equal. Okay? So I'm going to start with 12 over 8. I'm going to reduce that as much as I can. 12 over 8. I can divide both of those by 4. And I will end up with 3 over 2. Okay, so now with 7.5 over 5, I don't want to work with a decimal if I don't have to. So I'm going to try to make this a whole number. And I know that I can make this a whole number if I multiply by 10. So multiplying this by 10, 7.5 times 10 would move the decimal point one place to the right and would leave me with 75, which is a nice whole number that I can work with easy in my head. If I multiply the top by 10, in order to keep the fraction equal, I need to multiply the bottom by 10, and 5 times 10 is 50. So now what I'm working with is 75 over 50. And the only reason I did that was so I could have nice, easy whole numbers to work with, and I don't have to worry about decimals. Now I can divide or reduce 75 over 50 rather easily because I know that 25 goes into both of those. So I'm just going to divide both of those by 25. 75 divided by 25 is 3. And 50 divided by 25 is 2. I'm done. What I need to look at is once I've reduced everything as much that I can, I look at both sides of my proportion. Are they the same? In this case, they are. Okay? 3 over 2. 3 over 2, when that happens, you've just proven that you have similar triangles. These are similar. This is example number 1 in your book on page 61A. Why don't you pause the video and see if you can figure out if these are similar or not. Alright. Here's this problem all worked out, and I didn't put any labels on the vertices because I wanted you to figure out if you could see which two sides are corresponding. 12 is corresponding to 6 and 16 is corresponding to 8. So to set up your proportion, you needed to do 12 over its corresponding side, 6, and on the other side of the proportion, 16 over its corresponding side, 8. From there, you need to reduce both of these to see if they are proportional. Okay, so I'm going to do 12 over 6 first and reduce that. I know that both of those, 12 and 6, can be divided by 6, so I did that. 12 divided by 6 gives me 2. 6 divided by 6 gives me 1, and that cannot be reduced any further, so I'm done. The other side is 16 over 8, and I know that can be reduced by 8, so I did 16 divided by 8, gave me 2. 8 divided by 8 gave me 1. That cannot be reduced anymore either, so I'm done there. I put it back so they're equal to each other or in a proportion, and if they match, then these two triangles are similar. In this case, as well as the previous one, you should have come to the conclusion that these are similar because they are proportional. Alright, now here's example number 2. And example number 2 is going to be different from example number 1 because they already tell us that these triangles are similar. We already know that this triangle right here is similar to this triangle right here. What example number 2 is telling us to do is to set up a ratio from the vertical leg to the horizontal leg of both triangles to figure out the slope of the green line. So the first thing that I'm going to do is I'm going to do the vertical leg over the horizontal leg of the smaller triangle. So this is the vertical. Remember, vertical is up and down, and horizontal is side to side. So the ratio of the vertical leg to the horizontal leg of the smaller triangle is 2 over 3. Now of the bigger triangle, the ratio is 4 over 6. But that can be reduced, can't it? You can divide both by 2, and you'll get 2 over 3. Now you'll notice that our ratios are the same, which you would expect because the problem tells us that these two triangles are already similar. What it wants us to do is it wants us to find the slope of the line. This right here, when this is matching, that's your slope of the line. When those ratios are the same, that's your slope of the line. So the slope of this green line, we already know as being 2 over 3. And we can test that by doing rise over run. So if we go up 2 over 3, we'll be on the point. Up 2 over 3, we're on another point. Up 2 over 3, we're on another point. Up 2 over 3, on a point. Up 2 and over 3. Okay. That's how you use similar triangles to find the slope of a line. Alright, this one is all you. It wants you to, part A, draw two triangles that show the rise and the run of the line using points A and B and points M and N. And in part B, use the triangles to find the slope of the line. So pause this video, maybe draw this out and see if you can find this one on your own. Okay, so what I would do first is I would draw right triangles. And I would do so from A, I would go down until I am with M there. And then I would do another one from N down to B. And now I need to find the ratios of these two triangles. So let's see, let's go with triangle AM first. My rise would be 1, 2, 3, 4. So I know that there's 4 units here. And I would have to go over 2. And so my ratio for that one would be 4 over 2. Or I could divide that by 2. And I would get 2 over 1. And on the bottom triangle, I have to go 1, 2, 3, 4, and over, what do you know, 2. And so that's going to be rise again over run. I can divide those by 2, and then I should get 2 over 1, but I'm not quite done, or at least that answer is not correct. I need to be careful. Notice my green line is sloping down, okay? So working left to right, going from this point to this point, I'm going down, not up. So I need to make sure that both of these are negative, okay? is you are going down from left to right. Since this line, the green line, is sloping down from left to right, your slope needs to be negative. So the slope of this particular line is a -2 over 1. Part C just wants you to do A and B again, but to use different points on the same line, which you could do. You could go from point 29, and you could go to point N. You could use 5, 3, and go to point B. You would get the same thing as long as you pick a point that's on this line. You would get the same answer. I think that wraps up for us for this particular video. I hope this made sense and that you can do this. I will leave you with today's joke of the day. And the joke of the day is this: why did the farmer win an award? Because he was outstanding in his field. Alright guys, thank you for watching. We'll see you next time. Remember that you are loved.